Welcome back. Please read the problem. This is a case of resolution of forces or force in this case along non-perpendicular axis. So what you are asked is, you are asked to resolve this force 200 newtons along x and y axis and also along B and A. These are B and A are non-perpendicular axis. So first bit of the problem is straightforward. So because you are asked to resolve them along x and y, and we know how to do that because resolving the force along x direction is nothing but you just multiply the magnitude of the force by cos of the angle which that force makes with x-axis. Vertical component, you take sine of the same angle. So what you have is, let us do that first. So we have, I can say fxx along, so it is 200 cos 40, right? And fyy is 200 sine 40. And if you want the answers are 153.21 and this is 128.456. So these are that was pretty straightforward. So that is resolution along x and y axis. But we are asked to resolve this along A and B. So let me wipe it out. We want to resolve it along A and B. Now look at this. When you want to resolve the force along non-perpendicular axis, you can immediately find out, see, A and B, they are not, you are not told that they are perpendicular. Of course, there is one more force that is, angle that is given. So let me check that. Yes. This angle is also given. I forgot to mention this. 30 degrees, right? So this is also given. Now you want to resolve the force along A and B. So so the angle here is given as 30 plus 40 plus 30. That means the angle which these forces make is nearly it's 100 degrees. That means it's a non-perpendicular axis. So when you have such case, you should always invoke law of parallelogram of forces. So one way to deal with that is complete the parallelogram and find out the angles, different angles, and use the sine rule. And let's do that. So the way we will proceed is this. For the sake of simplicity, I suppose, let's say that this is so now we don't want x and y axis, so I'll just remove them so it becomes clean. But look at this. This is the resultant, and the angle which the resultant makes with B axis is 40 plus 30, that is 70, right? So what I do is remove the x-axis and write this as 70 for the sake of simplicity. So I'm removing the x-axis and this angle is 70, right? And let's say that the force here, I'll call this, there'll be some component here, and let's call them A and B, let's say. The force along this is A and B. Okay, so how will you complete the parallelogram? This is not drawn to scale because we don't know the magnitude. Let's assume this is drawn to scale, and this is also not drawn to scale because we don't have the magnitude. So what we do is, we complete the parallelogram, we have the resultant, and what we essentially do is, we draw a parallel to this line from the tip of this resultant, and wherever it cuts, that's going to be the magnitude of force B. And then similar procedure, draw a parallel line from this parallel to this from the tip of this arrowhead, then you will get the magnitude of A. So I'll do that. So let's say drawing parallel, I hope this is fine. So this gives me B, this is the magnitude, right? Magnitude of B. Similarly, I'll draw a parallel. We draw a parallel. So this is A. So we have completed the parallelogram. Now we have, so remember this, that there are two triangles and these two triangles are formed by a diagonal which is represents resultant, and always remember the diagonal has to start, because if you join these 2 points, that's also a diagonal, but the diagonal which we are considering has to start from the intersection of the tails of two vectors. So this is the vector B, this is vector A, and their resultant is this. So tail of these vectors is this. So diagonal has to start from here and join the opposite point, right? So this is R. So your R is 200. Fine. So what you have is, this is 70. Now look at this. These two lines are parallel, right? This R is a transverse. So this parallel. Let's consider these two lines. These two lines are parallel. This is transverse, right? A and A. These are parallel. This is the transverse. This is 30. So naturally this is also going to be 30. I hope you are convinced. Two lines parallel. This is the transverse. So this is 30. This is 30. This is also 30. This is 70, right? And this is 30. So what will be this angle? This angle, because this is a triangle, I can say this is O N, right? Or I should say O and Z, right? And P. Let's say O Z P. We are considering this. So we have this 70. This is 70 plus 30, 180 minus 30. Right, 70. So this is 80 degrees, right? So let me make it simple. I'll make it, this angle is 70, this is 80, this is 30, right? So we have we can now apply the sine rule. We can find out the angles, only thing is that here, so we can write the sine rule. What is the sine rule? Sine rule is R upon sine of 180. So we can say sine of 80, R by sine 80. This force is A by sine of 70, and this is B by sine 30, right? So R is known to you, which is 200. That means you can find out 200 by sine 80. Then you can find out A. Similarly, equate these two, find out B. Right? That's straightforward. So answer A is, if you do the calculation, A is 190.84 newtons and B is 101.54. Right? Hope this is clear. Thank you.